Okay, so let's do a couple of examples of plotting some points in XYZ space. So let's start with this one. 1, 2, 3. Well, first it's probably worth, here is our XYZ space. Just to give us a notion of scale, it could be worth it for us to draw some hash marks. I'll label them this time, but in general, I'm not necessarily going to label things completely. So let's see. In the X direction, let's see, I'll draw them like this. 1, 2, 3. Okay, so there's 1, 2, 3. In the Y direction, 1, 2, 3, 1, 2, 3. In the Z direction, 1, 2, 3, 1, 2, 3. There we go. Okay. So now I am going to go out 1 along the x-axis because 1 is my x-coordinate. So I start at the origin and I go out 1 along the x-axis to right here on the x-axis. After that, I go to my next coordinate, which is 2, which is y. And y is in this direction, so I take this point and I move 2 in the positive y direction. Note that I really want to go about 2 units. I don't want to draw the point like right under this 2 because the way that my, I've really moved off in this direction, the x direction, I need to move 2 units in the y direction. So this would be actually more than 2 units from this point. So I want to go about 1, 2. So that's about right. So there is 2 units in the y direction, and then finally I want to move up 3 units in the z direction, and so each unit is about that long. So 1, 2, 3. There is my 3 units in the z direction. It's worth it for me to label those, and then at the end of the day I should really just label what this point is. 1, 2, 3. Great. Let's try something a little bit more difficult. Over here we have -2, 3, -4. So the x-coordinate and my z-coordinate are negative. So what that means is that x is not going to go in the positive direction, it's going to go to the negative direction. I'm imagining this x is sort of coming out of the page at me. I'm instead going to draw it going farther, deeper into the page, away from me. Z, since positive z is up, negative z is going to be down. If y were negative, since y is kind of going to the right, I would have y going to the left. So I suppose the hardest idea here is x. So I'm going to extend my line to the back to maybe suggest that it's, I'm trying to draw it a little bit faint to suggest that it's going backwards, going away from the quadrant that we're dealing with, and just to make the picture look a little bit nicer. We'll draw the y there too. So here's my -x, -y, -z. And let's draw some hash marks just to give a sense of scale. And this time I'm not going to bother labeling them because things can get pretty messy. So x I need to go -2, y I need to go 1, 2, 3, and z I'm going to need to go -1, -2, -3, -4. So that's where we're going here. So starting with x, I move -2 to the back. Then moving on to y, which is 3, I move 1 unit, 2 units, 3 units in the positive y direction. And finally, I need to move 4 units in the negative z direction, -4 units in the z direction. So that's going to be something like 1, 2, 3, 4. Okay, that's -4. And at the end of the day, this gives me the point -2, 3, -4. Great. Finally, let's move on to this one over here, 1, 0, 1. And I only need 1 in the x direction and 1 in the z direction. I'm not going anywhere in the y direction. So I go 1 in the x direction. Great. The y direction is 0, so I don't move anywhere along the y-axis. Finally, the z coordinate is 1, So I move up a length of 1 along the z direction, and that gets me to this point right here, 1, 0, 1. Since we didn't move anywhere in the y direction, this point is actually on the xz plane. It's actually sitting on the xz plane. So generally, if we have x equal to 0, you're on the yz plane. If y is equal to 0, you're on the xz plane. And if z is equal to 0, you are on the xy plane. All right, I'd like to suggest a slightly different way for trying to plot points in three-dimensional space. Instead of going out along the x-axis and then moving the direction of the y and then in the direction of the z, another way is to imagine that the point that you're looking at is a corner on a rectangular box, specifically the corner on a box with these dimensions along each of these axes, x, y, z, that is opposite from where the origin is. So over here is our origin O, and let's just give ourselves a sense of scale, 1, 2, 1, 2, 3, 4, 5, and 1, 2, 3. So x is 2. Here is our side length of 2. This is going to be one of the dimensions of the box that we're looking at. Y is 5, so over here is another dimension of the box we're looking at. It has length 5. And then finally, z is 3, so here is the third side of the box we're looking at. So let me start filling out the box by sort of drawing some rectangles. The easiest is probably this YZ plane because it looks the flattest to us. Let me fill out the rectangle with sides 3 and 5. Now in the XY plane, I'll do the same thing. I'll draw a rectangle, but it's really a rectangle lying on this plane that's sort of lying horizontally. So it looks like a parallelogram to me, but it's really supposed to be a rectangle in the XY plane. Finally, I'll draw one in the XZ plane. Similarly, it's going to be a rectangle with side lengths 2 and 3. So here's this rectangle in the XZ plane, this rectangle in the YZ plane, and this one in the XY plane. And finally, these three rectangles, which meet at a bunch of right angles at the origin, they determine a box, a rectangular box. And this point right here is exactly, this point that's opposite from the origin is exactly what we're looking at. This is the point 2, 5, 3. And so this is another way of thinking about how to plot. And what's kind of nice about it is this sort of representation of a three-dimensional box, cube, whatever, is probably something you've seen before. So this, you've got that idea in your head when you see this. So question number 1, let's plot the following points in XYZ space. If you could do 2, 4, 3, 2, -1, 0, and -3, -2, 5, just as some practice. Go ahead, do it however you like.